Hello everyone, let's wait a few more minutes until joins us, and I'll also share the files for today's session. Okay, I think we can start. Hello everyone, welcome to today's session, and as you can see from the agenda today, we are going to finish our discussion about object-oriented programming. So we will not be able to discuss all the possible things on the topics of object-oriented programming, but we will manage to touch all the key points on object-oriented programming. So first of all, today we will start talking about abstraction. It's also additional feature used in object-oriented programming in Java and in basically almost all the object-oriented programming languages, with some specifications, some differences, but we will discuss it. And then I will also mention some key points about composition in Java. So also write the name of the presentation we will use here. Just a moment, so that will be easy for you to follow. So this is the name of the presentation used for composition and we'll finish the theory with polymorphism, and we'll just have summary of polymorphism in Java, and casting, which is also very important, but sometimes a little bit tricky thing to use. And we'll have this practical assignment I already shared with you last time. So we'll finally, hopefully today we'll finally manage to do it. So yeah, let's start. Before we start, I will remind you what we had last time. So let me open the Eclipse. So yeah, last time we discussed several important topics. We basically started talking about polymorphism in Java, and so this is the state when we use basically, yeah, in some cases it's stated as we use one object as another. So we basically consider one object as another object but the objects, the classes, and the object with one class as the object of another class, but these classes are different. It's the classes, the types, which in fact are different, but we consider one as basically as another. Yeah, as we seen last time, the person, the class person, and the class employee. So employee is also the person. So in fact we have we have object employee with the type employee, but this object is employee, and it is also the person. So in fact we have one object, but it is actually referred to two classes, yeah, to employee class and to person class as well. So there's basically one object with in fact two classes we can refer this object to. And this state is called like we used last time, inheritance. So we inherit one class from another, and as example we had the class person. We had the class person with we added some parameters to it, and we added some parameters. We added the constructor, and we added one method for the testing purpose. Then we created two subclasses, class employee and class CEO. In fact, we can also, in this scenario, we can also extend the class CEO from class employee. That's also possible, as I mentioned last time. In this case, I just wanted to show that we can inherit more than one class from each class, except for the in the case, I will quickly show this with you. If we declare the class as final, so in this case, if class is declared as final, we cannot extend. We won't be able to extend it anymore. So just additional thing I haven't mentioned last time, just for your information. Yeah. So I will write the comment. Maybe do all. That would be better. No, maybe that would be better if I write the comment above. Sorry, if the class is declared as final, it can be extended. So if you create the classes and you have the scenario when you definitely know that there is nothing in the hierarchy, nothing below this class, so nothing can be inherited from this class, so we cannot extend this class anymore. And then you can type final, and this will not allow other classes to extend your class. So that's as an option. But in this case here we did not use final because we wanted to extend this class, and we extended this class in two classes. Then we had the class employee, where we added additional parameters, and we can add additional parameters, and in addition we also have the access to protected parameters of the superclass. So in fact, when we extend the class, all the protected and public parameters now are also the part of employee. Private parameters are not the part, but protected and public parameters are the part of employee class in this case. And yeah, also as I mentioned, we also use we can also use protected access modifier. That's basically what is mostly needed, and it is mostly needed when we use inheritance. So just basically the properties of protected attributes are quite same as the properties for the private attributes, with additional feature that protected attributes will also be inherited in the subclasses. So in this case, we just defined that these attributes will also be placed in the subclasses. Alright, so that was this example, and also we can override the methods. So basically, again, the same as for the attributes, public and protected methods are inherited from the superclass. So if you don't override them, then the implementation from the superclass will be used. So basically, if this one is not here, basically comment it out or delete, then the describe method will be called from the person class. Yeah? This logic will be called if we don't write our logic here. Also, we can use super keyword. This will actually call the this will actually call the implementation from the superclass. So in fact, if the method is not overridden, it means that basically you can consider this that this logic is called super and the corresponding method name of the superclass. So that was about method overriding. We also talked about the constructors. So by default, the constructors, if there's constructor in the superclass, basically the constructor must be here. But if there's the logic written for the constructor in the superclass, this will always be called even if the object of the subclass is created. So we create, like in this case, we create the object of employee. Then the constructor of employee will be called, and the constructor of the person class should be called as well. So that happens automatically. We cannot construct the object of the subclass without the calling the constructor of the superclass. Basically, all the superclasses. If we have the hierarchy, when there is a subclass, then there is a superclass which has another superclass, which has another superclass, and so on and so on. Then all these constructors in the row will be called. So each constructor of each superclass will be called. And in case we define the constructor as parameterized constructor, so we have the parameters, then in this case we definitely need to override the constructor we need to create. Basically, we need to create the constructor, overload the constructor. We need to create the constructor, and Then from this constructor we will need to call the constructor of the superclass. So if we comment it out, yeah, you can see that this will be the error. Because again, basically the reasons why we need to override it, why we cannot just simply comment out and don't override the constructor overload. In this case, we overload, or we override plus we overload it as well. That's because again, as I said, constructor of the superclass must be called. But what's the idea here is, here we have only constructor which is parameterized. So like in case if we had the constructor which is not parameterized, and then we comment out the constructor from here, this should not be there should not be the error related to constructors anymore. Yeah, we have this error, but this is related to the thing that I just called the constructor, which does not exist. But in this case, we don't need to call the constructor from the superclass anymore. That's because we have an unparameterized constructor. So what basically Java does, Java sees that there's we have the class, there's the superclass, then Java firstly searches for the constructor. So if we unparameterized constructor, yeah, if we don't call call the constructor, so then Java searches for the parameterized constructor in the superclass, and if there's no such constructor, it means that superclass can only be created with the parameters. Like in this case, yeah, we can only create person with the parameters. We cannot create the person without the name, surname, and the age. We must provide these constructors to create the person. The same is for employee. Yeah, we cannot create employee. Yeah, in this case, if we comment it out, we basically have the same idea. Since employee is also the person, yeah, we cannot create employee without name and surname. And in this case, we need to call the constructor and provide all these parameters. So that's basically Java searches, what Java searches for. And yeah, I just mentioned, I think I haven't mentioned it yet, on Monday, that that if we extend the class, and if we have the object, yeah, we have the object employee, as I already mentioned in some way today, that the employee object, we have the object, and we can say that this object is employee, and at the same time we can say that this object is the person. So this is polymorphism, just explanation, and that in this case employee is object, employee is employee, and it is also the person. If we have if the person extends another class, for example any class, then we can also call that employee is also basically what it is in this superclass of person. So in this case, object is also the object employee is also the object of all the superclasses it has. Like in this case, it has one superclass. If person is also extended from different class, then we can also call the employee is referred to this class as well, and so on. So basically, yeah, that was the idea. And about the constructors, that should mandatorily be done. Alright, so that was about the constructors, about overriding, yeah. We talked, and we also touched the topic of overloading. Yeah, as I said, that's the state where we have method with the same name, methods with the same name, but with different parameters. So basically the only difference is that the parameters provided to the methods are different, and we can create as many methods with the same name, with the same output signature, but changing the parameters provided. So as an example, we had salary. So in case we calculate the salary in different we can calculate salary in different ways. Then for each of these ways we have different logic, we have different parameters we use in the logic, so we have different outputs. And that's the case, and we already, as I said, used different kinds of overriding. When we call system out, then there's print line, and you can pass not print line but print method. You can pass boolean, you can pass integer, you can pass string, and so on and so on. So there are different options for the same method. Yeah, this is how it looks. And in fact, in Java we don't pass optional parameters. In different languages we can pass optional parameters. In Java we cannot pass optional parameters, but we can achieve using of optional parameters by calling the method with actually different parameters. So in this case, if we have at least one parameter optional, then we can create the same method with different parameters, and then just don't use this parameter which is optional. Yeah, and this is the way we can escape if there's a possibility that we have optional parameter to be passed to the method. Otherwise, we need to provide all the parameters to the method. And basically, we already also used the overloading of the constructors. So remember, we had different parameters for the constructor, so we can have multiple constructors with different parameters. That's also the case where overloading is used. Alright, so that was from the previous session. To make it more clear, let's maybe create one example of the superclass, of using the superclass. So I'll use the same package inheritance, and I will create, imagine you have an account with the money. So that would be bank account. Bank account. So and then create main method as well, just for the testing purpose. Then under the bank account, we have amount of cash available. So that will be the integer amount of cash, and this will be the number. I will set as protected. Then so I will use protected. I will create getters and setters for this attribute, just to be able to get and set the values, not set the object. And then I'll have two methods. Withdraw money, so this will be public. It will be public. Then withdraw money, and then I will provide the amount of money withdraw. Then what I would that's the point. And I will first of all I will check if amount of cash is greater or the same as the amount to be fetched from the account. So if the amount is if there's enough money to fetch, then I will I will I will reduce the amount of cache available. That will be amount. Yeah, else if there is no such possibility, then I will print out that no money available. Not enough money. Money. As an option. So that would be the method, and another method would be to deposit money. Also print the quote. And here we will add the money. We'll add the money. And yeah, that will be it for our superclass. We'll use bank account as the superclass. Then we'll create two subclasses, and the first one would be investment account. So investment account is also the bank account. Yeah, at least in this case, yeah, there can be different options in real life, but one of the options would be that we have investment account, which is also the part of, which is also not the part of, but which is also the bank account, but with some different features. So yeah, we want to use main here, and I will extend the bank account class. And so here I have all the, it's not all, but just one protected attribute we have here, and yeah, just okay, a little bit later, and then yeah, so we have now we have the subclass, which will extend superclass bank account, and we will add the portfolio of, maybe let's use array list, and here I will array of strings, and here I will add the portfolio, then this would be array list. And this is the portfolio, which contains all the stocks we have in the account. So just let's store them as strings, yeah, just for understanding them. We'll not overcomplicate it with more complex object. We'll just use strings here. Stocks. We have the account. So we have, we can define this private if we want to extend this class anymore. I mean this class if we want to extend, then we can define it as private. And yeah, so here I can also add two options. The first option would be buy stock, and so I will pass the stock name here, and I will just append the stock I will add the stock to the portfolio. Stock name. So I will buy stock, Yeah, also I can add getters and setters as usually. This one, get portfolio, and set. No, we want to set portfolio. Yeah, that's also the trick for. Basically, yeah, there's no need to. In this cases, yeah, there's it's practically impossible to imagine the case when if we have the list and list as the attribute of the class, attribute of the object. Then if we if we create the object with the area list at the beginning of the definition, then there's practically no, usually there's no reason to have setter on portfolio. Why? Because usually just have one list, one object, and we won't replace it. Yeah, because that doesn't make sense. Usually, at least I cannot imagine the scenarios when we need to replace the list which is assigned as, which is created as the attribute. Yeah. In this case, we just have object created at the definition. Then this object will always be used, and that's why we don't need setter method, because setter would only be needed it can only be needed if we want to replace the object. But since I cannot imagine, we usually don't need to replace the lists, because again we have the list as the object created. Then this list will be just used during the lifetime of this object investment account. Then we can get to change the content of this list. We'll get portfolio, and get basically this will provide us the list, and then we can manipulate with this list by adding the parameters, changing parameters, and so on. So in this case, we won't need the setter for the list, and we usually don't need the setters to be used in the list. So that's yeah. Now we have getter, and we have method byStock. We can also use create the method sellStock. Then we will again provide the stock name to be sold. And here we will need to also to check if such stock is available. So what we can do, we go to our portfolio, then we call the method contains, and then we can check if such stock exists. So check if the stock exists in the portfolio. So we check if stock exists, then we remove it. So to remove it, yeah, we can call the method remove and pass the stock name to be removed. Otherwise, yeah, we can print that the stock does not exist in portfolio. Stock name does not exist in the portfolio. Alright, so now we have all the properties of investment account. Yeah, it's the same as bank account with some additional features like we can buy stock, we can sell stock, we can use the portfolio, but remember that all these things like amount of cash and deposit or put or withdraw money, this attribute and all these methods will be available for inside this class as well. And let's create let's create another method or another class which will also extend bank account class. So this would be savings account, and yeah, this will also extend the bank account class. And in addition to the methods and the attribute in bank account class, we will have the method. We'll have the attributes like term. So if we have savings, then we usually use the term for the savings, at least the term during which period we cannot withdraw the money. So I will use this method, this attribute here. Term for the savings. Term, and then I will have percent. Let's demolish everything. Okay, so we have term, then we will have percent, so of savings, which will be added to the savings, and then what we have, and yeah, that would be it for the additional parameters. We can generate getters and setters for both these parameters. Moment, I will solve an issue quickly. Okay, so I generated setters and I will also generate getters. Getters for these parameters, and yeah, basically I won't add any new methods. I will override existing. So, and existing would be, okay, we can deposit, we can add more money to our account, but we can also override the method, which would be the method, yeah, we cannot, yeah, since this is the saving account, we have some restrictions of fetching the money from this account, because that's savings account. We cannot just access this account, but we cannot get the money from this account at every moment we want. That's why we need to add some restrictions, and the restrictions would be oh yeah, one moment. What we can add is the term passed. So this would be, so if we have 10 years of term and there are 10 years passed, then we can also, from this point we can withdraw the money from the account. So if the term is greater than term passed, then we can withdraw the money. We can use super method from the super class. That would be correct. But if the term is not reached, then I will print that you can't withdraw the money. So this would be the structure for our class. For our classes, and this is basically the structure. We have two subclasses, and we have one superclass, which is used in both these classes. So this is about this example. And one thing that I forgot to discuss last time about superclasses is that in Java there's such property that in fact all the classes are inherited from one class, and this class is called object. So all the classes at some point of level are come from object class. Yeah. I'm not sure if we already used it before, but this is the class which basically defines all other classes. Yeah, so as an example, maybe let's create a new package. No, maybe I will use the same package. Some test object class. So what we can see, this is object class. It comes from Java language, so this is basically it says that's the root in the hierarchy of all the classes. And what does it mean? Oh, that's the casting. Okay, maybe I will talk about casting a little bit later, as I promised. But for example, if we have any reference type like string, we add something here, and for each class, if you look deeper, then we can see, basically we can see the methods and the attributes in each class, and we can also see the class from which the corresponding method comes. And basically for all the classes, if we scroll a little bit down, we can see there are the methods which belong to the class object. For example, get class. So actually return the class. Then there's the method. There are the methods notify, which is rarely used. That's related to threads. We will not use it. But what we did use is the method toString, for example. The method toString. In this case it is overridden. In this case toString is the method which is already overridden. That's why it comes from string class, and that's why toString for string basically means the content of the string. This one, and this is basically why the string work in this way. So if you may ask the question why basically strings are not quite the same as other objects. In fact, they're the same, because if we print the string, for example, if the string is printed, for example, print line string camp, so there's just text printed. But what we will see, so there's text printed, and if we call the method toString, so this basically should be the same. So in fact, it is already written in this way. But even for object we created, class we created, and the object to be used. So here's the method, and for all the objects, we have such option to call the method toString, and this is one of the methods which come from the object class, as I said. And this basically means that the object will be described, translated to string. Yeah, for example, if we have the object, then we can override the method toString, as you remember. And this will, and here we can type the object, which will show us, which can show us the main things about the current object. That's toString, and also one method which we won't use right now, but which is also usually used, is the method clone. This is protected method, but it is usually used, and basically it is needed to clone the objects. About the cloning we will talk other time, not now, because that would take the time and the explanation would be long. But yeah, that's just for your information that the method clone is usually used, and it also comes from the object class. Basically, yeah, that's the class object, and there are some properties inherited, not some, but all the protected and public properties are inherited from this object class. So all the classes come from object. And that's the point to be understand, for you to understand. And yeah, when we talk about casting, we'll talk about the casting today. Here is, when we talk about the casting, we'll see how we can use object class. But that will be part of casting topic. Alright, so that's about what we had last time. If you have any questions, then you're welcome to ask them. You can briefly write the questions if you want. At the same time, I will start with the presentation about abstraction. So this is also the feature. Yeah, abstraction. That's also the feature used in Java, in addition to all the previous features we had, and it is also related to polymorphism, and it is also related to the inheritance. And we'll see how. So there are basically two types how can we achieve the abstraction in Java. In Java and in not most, but lots of other programming languages. Yeah, and there are two types, and these types are abstract classes and interfaces. So we will see what are the differences between them, how to use them, and what are the advantages and disadvantages of them. So just first note, then in Java we have both options, abstract classes and interfaces. If you go to C++, for example, there are no interfaces there, but there's the option multiple inheritance, which helps achieve features of the interface. But we'll talk about all these things right now. So first of all, let's start with abstract classes. Abstract classes. Yeah, so the presentation shared as you last time, so there are no too much slides. We'll go through the examples and we'll show how to. So abstract classes in Java. So basically, what's the motivation for all these for the abstraction? Yeah? So basically, why do we need the abstraction? In fact, so again, as for lots of features in Java and not only Java. In fact, you can, in theory, work without them. The same way you can work without the object-oriented programming. That would be possible to achieve all the things we can do with object-oriented programming, but that will take much more time, resources, and than object-oriented programming would take. In addition, without all these things, the structure of your program would be very complicated. It won't be understandable, and basically that's not what we want to achieve in programming. Again, because just maybe some small note about the programming. In programming, the idea for us is maybe to not create something like a mega super complicated algorithm with thousands features, thousands of tricks used, but at the result, if if there's the algorithm with thousands and thousands of tricks and points and approaches used, then at the end you can imagine that the code only a few people in the world would understand this program. There are some jokes about the programming, some memes about the programming. For example, the programmer says like a year ago only I and God knew how this code works. So the year passed, and now the programmer says now only God knows how this program works. The same is for basically that's basically the idea of the code we want to write. We want to write the code so every person can understand. Of course, every person who knows programming, how this program works, what can be changed, what cannot be changed. So what cannot be changed, what can be changed, what can be adjusted, what cannot be adjusted, how all these things work, and basically the main thing to achieve is so that the person who read the code, to make this person understand basically what was the idea, why this all the things were written. And that's basically why we have all these inheritance, all these classes. You have to have reusability, to make it easier to store the code and to manage the code. And one of additional options to achieve it is abstraction. So what does it mean? As the example, we want to describe the object, the object which comes from real life, and any object. And the problem may be that this object, basically we know the class, we know the things this object can do, the things this object has, as the attributes, as the properties. But the problem is that basically we know one common object, but in fact one common class, common description. But this description, these options cannot be applied to all the if you already know what the subclasses is. So we have the class, and we cannot create any object from this class. It's undefined in some cases. Yeah, there's some things which cannot be defined as the pieces of this class. But what can be done is that we can have the subclasses. Which actually are fully described, and these subclasses contain the features, attributes, and methods from the superclass. So basically, if we talk from the technical point of view, then we have the class, which first of all cannot be the object. Yeah? So we cannot create the object using this class. And some methods. There are some methods which basically cannot be defined. So we have the structure of the methods, we have the name of the method, we have the parameters, but we don't have the logic for this method. So we don't actually know what to write under the logic of this method. And there are the subclasses which can be used, basically other classes which can extend this class. And for these classes, we can actually fill all these methods. Yeah, we can write, basically we can override and write the logic for all these methods. But again, the superclass cannot be the object itself. So there's it is not fully defined. Yeah, what we can say, that there's the class which is not fully defined, and by not fully defined I mean that there can be the methods which won't have the implementation, and we can call, and these classes are called abstract classes. So yeah, we want to restrict and the class to be used to create the object. Yeah, that was I wanted to say. Yeah, so. And these classes are called abstract classes in Java. So basically these are the classes which, just shortly, these are the classes which, first of all, we cannot create the objects from them. So if we have the class A defined as abstract class, then we cannot create the object of A. We can call new A, it won't create the object for us. Yeah, that's for the abstract classes. That's first of all. And secondly, you can define the methods, you can define the signature of the methods, name of the method, then the parameters of the method, but you can skip. Yeah, it is not mandatory, you can have the implementation, but you can, if it's necessary, you can skip defining the implementation for the method. For the method, one or several methods, and this is called abstract classes. Yeah, basically not only so the things I just said that is related to the abstract classes, but if we have the idea that we have something which can be described as not fully described, that is called abstraction in Java. So that's the short introduction to the abstraction in Java. And at this point, I think we can have the break. And after the break, we will start talking about abstract classes. Okay, so let's continue with the abstraction. So we just talked about the motivation. So basically, the idea is that we want to restrict the access, the possibility to create the object, and we want to add the possibility to not fully implement the class. And also, if in some case, if we talk about the interfaces, and maybe if we go a bit ahead, then the idea would be to have some common properties, which some different set of properties which can be used in different classes, different sets of properties, which can be used in one class. But yeah, this is about interfaces. We'll talk later a little bit. But the basis, something which is not fully defined, this can be used, can be created first, and then can be used in other classes. But yeah, for example, what can be the example? So I've selected two examples, and excuse me. The first one would be example class animal. So in fact, we know that there is such class animal. Yeah, that's obviously we have animals. But is it actually possible to have the animal as the object without any specifications? No, because animal is just with the class of the animals. There are different animals with all the different yeah, we can say properties, all different things. Yeah, we know that there is such class, but it is not possible to create the object, because there is no such object like animal. Yeah? There's only the, like if we can see here, there are snakes, there are dogs. So all these classes can be specifications can be used as the object. Yeah, we have the object dog. Yeah, dog. Yeah, we have the object snake. Yeah, but we don't have the object animal. And for example, what we can see, the class animal has the methods sound, yeah, which animal can provide, and move. But again, the problem is that for the sound method, yeah, there's no unique sound for all the animals. All the animals provide different sounds, and there's nothing in common between them. So if we have the sound from snake, then the sound is the snake hisses. The dog barks. Then what about the movement? Yeah, also all the animals move differently. For example, snake switters, and dog runs. And so there's different specific here. But the key thing here is that there is no common thing to describe and these methods. But we know that every type of animals sound in some way, and all the animals will have this opportunity to provide the sounds, and also all the animals can move in some way, but they do it differently. So there's nothing in common to just have to define it in the class animal. Yeah, if we talk from programming perspective, then we have the methods, but we don't actually know what to implement in these methods. Of course, in theory, we can just keep empty implementations. We can just create the method without any code inside, so we can do it in fact. But would it be a nice approach to use? I don't think so. So imagine you have the class where there are not tens, or just maybe 2, 3 or more methods without the code. And basically the question for the programmer would be, why do we have all these methods if none of them has the code? Yeah, so in this case we don't actually want to escape, declaring the methods with just empty code. But what we can do, we can use abstract classes. Yeah. And another example would be the code file, so we have the file with the code, and so again there is no code, just from nothing. Yeah, for each code is written in some programming language, and again you can see that there cannot be such object as simply code file. Yeah, it should be specified for us to be able to declare to create the object from using this class. And as an example, we can have the method compile in this class, and basically again, if we do the compilation of the code, it is there's imagine there's no unique compilation methods for compilation logic for all the classes, for all the codes, for all the classes. But what we do know that for each type of programming languages, for each type of code, from each programming language, there is such needs to compile the code to be able to execute this code. And that's why we have the class code file where we define the method compile. But again, we don't have the logic to implement there. So we keep this method as is, and then we use this class in the classes Java code file, and then inside these methods we use Java compiler to compile the code, and the same for C code. We use C compiler to compile C code. So we have the method, but the method will be implemented in these classes only, as an example. And here we go to the abstract classes, and basically what the abstract classes are in Java. So there are so how abstract class is defined. So abstract class, this is also the class. Which can be defined using the access modifier. Again, we usually use public for the files. Yeah. So let's remember, we use public class for the files. Then we just basically have all the same definition. We just add one more. I will underline. Yeah, we just use one more keyword. The keyword is abstract. So if we use abstract keyword, this means that we define abstract class. So what are the differences in this? What are the differences comparing to the simple classes in abstract classes? So the same as for the classes, simple classes. We can have the methods, private, protected, or public, but for public and protected methods, it is possible to have no implementation. So we can define the methods, but we can skip implementing them. So for the abstract classes, this would be correct. Then, another thing is what I already said. we cannot create the object using the abstract class. So instead we cannot type new, then after new we cannot type a type of abstract class. It is not allowed to be done in Java. For all the other things, yeah, about no implementation, I mentioned, please note that I mentioned protected and public. We cannot have private abstract methods. We'll see why. We'll see why. Yeah, but all the other properties, coding, are the same as for the standard classes. Same as for standard classes. Simple. As for the other classes, we can have the attributes, we can have the methods, we can have private methods which are not, which have the implementation, and interfere in the same way as we do with the simple class. And another point I forgot to mention is that abstract classes are used as the superclasses of other classes. So basically, yeah, I already mentioned that here that we have the abstract class, then we have the subclasses. So, and the subclasses are just a simple class, can be just simple classes with no abstract keyword. That means that these are fully defined classes, and we extend and we inherit these classes from the abstract class. And as I just mentioned about protected and public attributes, protected methods with no implementation, when we inherit, when we extend the abstract class, then all the methods with no implementation must be implemented. So we need to override them, and we need to override all the we call them abstract methods. Yeah, if the method does not contain the implementation, we call it as abstract method. So all the abstract methods should be implemented in the subclasses. So we need to override the method from the superclass, from the abstract class. And so here I can ask the question to you. So based on what I just talked, I said that we can only define protected and public methods as abstract. But the question for you is why it is not possible to define the abstract methods as private. So that would be the question to you, based on what I just said. So any guesses why can't we define the abstract method as private? So again, this is the method which is defined and can be used in the subclasses, but it does not have the implementation. So we define this method to be able to implement it in the subclasses. So any guesses why it's not possible to define it? Basically, there's no sense. Yeah, it's not possible, and there's no actual sense to define the method as such method as private. Any guesses? No? Yes. Yeah. Okay. The key thing is that, as we already know, that the private methods will not be inherited. So if we define the abstract method in the abstract class with no implementation, it won't be available in the subclasses. So we cannot implement it in any way, because it is not available in subclasses. That's why we just create the method without the implementation. It cannot be implemented, and there's actually no sense of this method which cannot be implemented. And that's why it is not allowed to define private abstract methods. Okay, so just to have the example, we can I'll show you one example for the abstract classes. So as an example, yeah, we can also define it here, and the class would be shape. So yeah, I've created package before. Just make it more understandable. And yeah, here I will create the abstract class, and the class name is shape as I already said. So I can take abstract. This will basically just add the keyword here. So now we have abstract class, and since we have the shape, yeah, so there is one thing common for all the shapes. This thing is area get area. So for all the shapes we can get the area. But again, the question is there public void? Oh yeah, abstract. Sorry, abstract. Abstract. So yeah, but the question is there any common logic to calculate the shape for all the area for all the shapes? Oh, because again for the circles we have we just have radius, and yeah, we have radius, and based on the radius we can calculate the area. Then if we talk about triangles, then we have the height, then we can calculate the area using the height, or just using the formula for all the, if we just if we use all the edges for the calculation. And for the rectangle we have the width and we have the height. So based on these two parameters we can calculate the area, but there is no common logic for all the the shapes. That's why what we can do, but again, all the shapes have this method, get area. For all the shapes we can calculate the area, but again, since we don't know what to write for all the shapes, we define this method as abstract, and we don't define the implementation. So now we will have this method, but we don't have any logic inside. Yeah, and just before we start implementing subclasses, I will create main method, and yeah, the main method is a static method. So for the static methods, there are no differences comparing to the simple classes. Yeah, one more point about abstract classes. Yeah, just one suggestion, comment from my side and from my experience. Abstract classes can also be used if you don't have any instance attributes and instance methods. So if you only have a static attribute and static methods, you can simply use abstract classes. Yeah, again, as I already said, abstract classes we cannot instantiate. Abstract classes we cannot create. This means that we cannot create the objects from the abstract classes. And if you have all the things, all the methods, all the attributes static, then we don't need the object, and to be created from this class, and then we can define this class as abstract. That will be fine for us. Yeah, that's why for I'll just write a comment. For static methods, no differences comparing to the standard classes. So yeah, we can use again main method. This will work in the same way. And as I said, just to show you, we cannot instantiate abstract classes. You'll see the corresponding error. We cannot instantiate type shape. This is what I said. Cannot create the object. Object is right in our case. Cannot create the object from the abstract classes. Then it is not possible to create. Let's just do something. So right now we have okay, we can also calculate the perimeter as well, just to make it more, to add more functionality. Method also as an option of get the v, and we can get the perimeter as well. Yeah. And I think we can, at least I can't imagine any attributes we can add for all the shapes. Yeah, so that would be enough. We have these two methods. So right now let's move to the standard classes and what kind of shapes can we have. Let's start with circle. So we have the class circle, and this will be the standard class. And what, again, as I said, standard abstract classes can be extended from the we can extend abstract classes in standard classes, and also in abstract classes it is possible that we extend abstract class from the abstract class. There's also such option as for all the other classes. But again, we still won't be able to instantiate the class if it is defined as abstract. But we can inherit. But it can be inherited from the abstract class as well. So yeah, now let's extend the class shape. And now, as I said, we have the error. We have the error which shows us that we need to implement abstract classes. So first I will turn the comment. All the methods must be implemented. Without it, you'll have the errors. And so I'll do it here. Get area method I need to implement. And for the circles, we have radius. Radius, I will define this private. And I will generate getters and setters. Wait, so not this one, but we'll need this one as well. Get and set radius. So right now, I can get array and sorry, yeah, that was my mistake. Not void, but integer. Since we want to return the the value, define them as integers. Oh, so this one. Yeah. So now we can override them, and I will return this power of 2. So value of math class. Times. Maybe let's use double. Yeah, maybe let's just replace these doubles because we have the let's maybe work with. It's more complicated, but okay, that's not important for us. We can, but yeah, it's not important for us. Let's keep working with integers. If we don't provide non-integer radius, then however we have pi, so let's find, and yeah, let's use doubles. That would be more flexible for us if we use doubles. Okay, so I will replace just integers with doubles. Radius as well. That will be more flexible for us. Okay, and this one will be replaced as well. So then I multiply by radius and I put it in power of 2. And then the radius, and then I try the power square 2, and it's still the error because we must implement another method to get the parameter. And for the parameter, for the cycle, this will be 2 times. Yes, and the radius. So right now we implemented abstract. We extended the abstract class and we implemented all the abstract methods. Yeah, and maybe just one more thing, as I said, just for test purpose, we can see that private if I define if I get something just for testing, you will see that it's not able to do it because, again, as I said, private abstract methods cannot be created. That's what I said. But protected can be. It's good for you. Yeah, I also commented on, but just protected. Yeah, it is possible. It is possible to define protected abstract methods. Just small amount. So right now we implemented circle class using the abstract class. So again, we use it as the super class, and right now it acts like every super class. So all the public and protected methods are inherited. Alright, so now let's create 3 more classes, just make it more understandable. So we have triangle, and oh yeah, so just one more thing, just for you to see. Yeah, as you can see, it has by default defined that the superclass is Java-like object. We cannot think even in this case, just for testing. So, yeah, even for this, even if we don't I'll delete it. That's just for test. Even if we don't type object class here, this will be added automatically. So it's not possible to create the class without without extending object class. That's just a small remark from my side. Okay, so let's create the class triangle, and I will extend the class shape again. Again, it asks us to implement the methods. So first of all, for the triangle, we have edges. So I will define them as edge 1, edge 2, and edge 3. And yeah, let's just not write a complicated formula for the area using the shapes, using the edges. We can also define the height. And yeah, so to get the area, against H1. So I'll also generate getters and setters. H2, get H3, same for the setters. And also get so right now we can get the area. The area would be we divide by 5 or divide by 2, and we multiply the edge times the height against this edge. So that will be the area, and for the perimeter we need to sum all the edges. And the last one. And the last edge. So now we get the perimeter for all the for our triangle. And that's it. That's basically it for this class. So we extended the class shape, and we added additional parameters which are needed to have the class triangle. And so that's it for this class. And the last class will create this rectangle. So for rectangle again we will extend the abstract class, the class shape, and again what we will add with integer. Okay, let's use double. Did I use integer or double here? Or use integer. Okay, that will be fine. And we can change it to double if we want, but integer will be fine in this case as well. Then okay, here let's use double. Then we have width and we have height. Then I will generate setters and vectors. And yeah, then to get real, we need to simply multiply 3 by this. And to get the perimeter, we need to basically sum all the edges, and that would be 2 times. Okay, and yeah, we can use brackets here, and this is fine. So yeah, right now we implemented all these methods, and basically yeah, so now we have all these 3 classes, and all of them extend one abstract class, one super class, which is abstract class. So if we talk about the inheriting, then almost everything almost everything works the same way as for simple, if we extend a standard class, with one exception, that all the abstract methods must be implemented. Yeah, so this is, and in fact abstract classes usually are used in the cases when it's also for the generic programs. I mean, the generic classes which are written in Java libraries, they are placed in Java libraries. Then for some objects, basically for some classes, we are not able to create the objects, and Java don't want us to create these objects, and these classes are defined as abstract. Also, one thing which is not used in Java, but in case you work with C languages or other languages, in some languages there's such option like friend classes, and friend classes basically that's the option what we say, that's the option how to escape the features, the definition of object-oriented programming, some definitions of object-oriented programming. But in Java there are no friends classes, but in other programming languages there is such feature like friends classes. But it is rarely used, and just if you can work with different programming languages, then sometimes you may face friends classes, and if the friends classes are used, then there are some exceptions from the main theory about the inheritance, about the access modifiers, but that's a different topic. What else do we have in inheritance? Yes, since we'll move to interfaces as our next topic. Before we move it, I would like to not summarize, but maybe quickly in overall to summarize the inheritance from the superclasses. So, just main things, what we have. First of all, we have the methods which are inherited, and public and protected methods which are inherited and can be used in the subclasses. And we can also override these methods in the subclasses. It is possible, then all the attributes, also protected and public, are inherited and also can be used. We can use super keyboard to access the implementation of the corresponding methods in the superclasses, so we can do it. Then we have the constructors, which in each class, in each superclass will be called. Yeah, if you have the class with one superclass, then another which has another superclass, and so on and so on. So all the constructors will be triggered. Yeah, that's about it. And the last thing is why I just started summarizing everything is the thing that we can extend only one class. Yeah, that was as an option. Maybe let's try to extend as rectangle. Yeah, just as an example. We can see that it is not possible, and we cannot extend more than one class. Yeah, this is what we have in Java. Only one class can be extended in each class. Yeah. So we don't have so-called thing like multiple inheritance. This is, yeah, if comparing to C++, in C++ there is such thing like multiple inheritance. So the option is that there is more than one superclass defined under defined in the class. It is possible in C++, but it is not possible in Java. And basically, what may be the problem if there are if there are more than one superclasses in the class defined, is that if we have, for example, imagine we have the methods in each superclass which have the same signatures and have the same parameters. Yeah, so we have in both superclasses, and they both are public or protected. So imagine we have such methods with the same names, same parameter signature. Then if we want to extend both these classes, what we will have? We will have the situation when we inherit the methods with the same names, with the same signature from both classes. And the question would be which implementation to use, because normally the implementation of the superclass is used when we don't override anything. If we don't override, then the implementation from the superclass is used on the methods. But again, if we have these methods implemented in two classes, so in this case for the program, that would be confusing which one to use. So in this case, in Java, there is no such possibility to extend more than one class. But what we can do in Java is that we can use the interfaces. We can use the interfaces, of course. Current presentation, and I will open the presentation. But there's it is located in the PDF, so we can open it. 1 moment. Interfaces. So it is located on 13 lines. So here it is. Yeah, okay, so we will start from here. So basically, as I just already introduced, what's the motivation? The motivation is that imagine that we have some common properties, common methods, which can be, we can just define these methods, yeah, but so they're public methods, we can define them, so there are such methods with the corresponding signatures. But again, the question is, so what can we do if we have not tens, but maybe we have multiple such things which can be assigned to the classes. So, example, we have some place where the methods are stored. Yeah, okay, we can call them interfaces. So this place will be interfaces. So we have the place where we have definition of the methods, and so yeah, there are multiple such places where the methods are defined. So previously we just had one place for each class. This place is the superclass, and all these methods are defined there. But as I just said, what we can do if we want to just simply have if we want to extend the methods from methods without implementation, with no implementation, so we won't have any conflicts with different interfaces. So imagine that we have different places where these different methods are stored. So there's not just only one place, there are 5 places, for example, or 3 or 4, or just multiple places. And each place has the methods. Methods, basically abstract methods, you can call them. Each place has methods without the implementation. And different classes, we may have different combination of all these interfaces to use. So the motivation is to have multiple places with basically multiple sets of the sets. Each sets contain the methods with some meaning, and we can use the combination of these methods in of these sets in different classes. And for this purpose we can use Java interfaces. So as it states here, we can manipulate objects without knowing how they work. That's also the concept. As I just said, the methods will not be implemented. So they will be defined, but they won't be implemented. And so a moment, just figure it out. No, that's correct. So you have similar but not identical objects. So we cannot really just simply type that these objects are identical, but they are similar. So we have some parameters which can be combined for the class. And we want to reuse them. So so that was the introduction about the interfaces. Right now let's have the break, and after the break we will discuss interfaces. Okay, so let's continue talking about Java interfaces. So as I said, we need to have such option to have to combine multiple combine the sets of multiple of the methods, multiple sets of the methods in one class. So how to achieve it, and basically how does this can be done. So first of all, let's see the simple example with without using the interfaces. So imagine that we have a class where we need to draw. So for example, we use the class bouncing box, then we have the method draw. Then we use the graphics, and basically it draws us the boxes. And then there's the method flower, which also has the method draw, but since there is no relations between flower and bouncing box, so we cannot define flower as the for example, as the subclass of the bouncing box, or vice versa. That's or the bouncing box as the subclass of flower. That doesn't make sense, and this is not how object-oriented, how inheritance work. That's not how it is done. So basically, but still we see that they have the same methods. So what they have the same methods. Next one. So as option, so here's the class, draw graphics, and for each, for example, how it can be done. So we have the class, how in this case that was done, and how this can be improved. So this is how it was done previously, without using the interfaces. So we have the boxes, we have flowers, we have cars also as an option. Then we draw all of them. We draw all of them without using any interfaces. But yeah, we have this method draw. It is defined in each class. In each class we define this method draw. But since for drawing we know that drawable objects all have these options like to draw and maybe other options, but at the moment we talk about draw. So all the drawable objects can be we can draw all of them. So this is how it is done in just without using the interfaces. So we just define the methods. And in this case we need to define again the same method in all these classes. In all these classes we need to define the same method. But does it make sense that we define the method 3 times? Not, I don't think so. But all of them actually all these classes have this method. So and basically what are the interfaces and how interfaces can help us. As I said, this is set of classes. You can call basically interfaces are not the classes, but this is the set which share methods with the classes or with other interfaces. So we declare an interface with the common methods. So we have the interface, and then there are methods with similar meaning, and then we can use interface without knowing an object specific type. This is a part of casting we need to we talk about it. So I need to mention it. So yeah, and this is how we can implement creation of the interfaces. So again, as I said, we have three classes. Again, if you go back, we have three classes, and each class from each class we can call the method draw. So it means that all these classes are drawable. Yeah. So to create the interface, yeah. So just to put this characteristic to all these classes, we can create the interface, and inside the interface we can define in fact these are abstract methods without any logic there. So we have two methods, draw and set color, for example. For all the classes where this interface will be used, there will be the methods draw and set color, and this is so how now the class flower will, basically all other classes will look like. So we have a class name, and we use keyword implements, and then we provide the name of the interface. And so if we provide the name of the interface, then we will need to override, basically to override all the methods from the interface, and then we will have the method which can be used under the subject. So just small notes about the interfaces. So inside the interface we can have the methods only. That's mostly true. We can also have constants, but constants are rarely used in the interfaces. But as an option, also constants can be used. But mostly this is we talk about the methods. We have the methods, which are abstract, and we can use them in the classes. We don't provide the code, only the definition, so signature. We provide the signatures of the methods. Basically the same as in the abstract class, with one exception, that in the abstract class we can have the methods with the implementation, but in the interfaces it is not possible to do. And also regarding multiple inheritance, we cannot we cannot extend multiple superclasses, but we can use multiple interfaces. And so as an option, so how to use them, we can only access stuff in the interface using the method call. And this is called casting. So here you can see casting. Again, as I said, I can mention it, but I'll separately talk about the casting, because this is really tricky thing to understand. So that's why before I explain how the casting works on the interfaces, I don't want to go deep on the casting, but just with small note that interfaces will also can be used, and they are used as part of the casting in Java. But again, I will talk about the casting separately. So it's just a note that for interfaces we have such thing like casting used. So let's explain it using the example. So I prepared the example. So and we will use class person for our purpose, and yeah, we will use yeah, we'll use the class person as an option. So yeah, as you can see here, we have the class person. Then no, maybe let's do differently. I will create a new class. I'll create a new class, and I will create a class, for example, the class being man, for example. That's one man. And so I'll play the class for man, and we will extend. So this is what we already did. We already did. It's already done. Yeah. We use the super class person. And what was the issue here? Oh yeah, constructor. So we need to define the constructor. So there was, let me just copy paste, and I will, so I can use the constructor. So we'll start the constructor, and I will just pass all these parameters name, so name, and page. And I will create the interfaces. Two interfaces. So the first interface would be player. For example, we can point that person, that the man is the class man. This is the class of. This is the class, and it will have the interface player. What does it mean? It means that this object also has the properties of player. Yes, so let's imagine that the man is player. So this is the class of the mans who are players as well. And yeah, so the player can play, for example. So using this interface, we can define the method play. Okay, so as a simple option, man can play, and we using the keyword implements, we can implement that this is the class, so mans who play, who are players, for example, if that's football player or just any game. But we point that this and this is the class of yeah, maybe just I would like to say it would be not man, but sorry, specific person. Yeah, I didn't like to use man, but I would call it something like that. That would make more sense. So, and I will also rename the class. I'm sorry, that was just I just accidentally noticed that if you use man, this won't be really correct. So I will rename specific person. So that would make more sense. So we have the class of specific persons. Yeah. This would make more sense. So specific things. And so what's the issue now? Oh yeah, that's the thing. So now we need to define a constructor. Okay. Sorry, that's the issue. Okay, and oh yeah, and now again, as you can see, it extends person, so we use the constructor, and then as I just added, we extend interface player. So it means that the person, specific person, the person's player. So yeah, and we can add the attribute game, which game person plays, and setter. Here I will print which game is played. So now that name, surname, this name, and this surname, place, game. Yeah, so this is, as also we have interface, basically something similar to abstract classes, but again, in this case we can see that we have the methods inherited from the person class and from the player interface as well, so we have multiple inheritance. Yeah. Here we have just one method, but this interface can be used in the same way as abstract classes and multiple classes. Comparing to the abstract classes or simple classes, standard classes, we have one difference, and the difference is that we, as I just said, we can extend, we can implement multiple interfaces under one class. So right now we will create another interface, and the interface name will be parent. So a specific person, the person is the gamer, and and the person is the parent as well. So yeah. So I can add the method field feed children, for example. So, and what can I do? Yeah, I will create another person as the object, and here I will add kit, and I will set it. And so here this will be, and now I will implement method feed. Yeah, so I haven't ported that I will implement this method, so I will type it here, and I will type it. So now, as you can see, we have multiple interfaces, and from each interface there will be the methods we can use. So we can use, yeah. So now we need to implement method feed. And what I can do, I will also to the person, I will so I will add another attribute to the person. I will add stomach full. Somebody forgot to be false, and I will define the method feed. This will So change the state of stomach to true. Stomach full to true. And so what I will do, I will feed this eat. So yeah, now we implemented second interface. So now we have one super class and we have two interfaces. So we can combine them and so as an option, again, we can have more different combinations of the interfaces. We won't have any conflicts because we don't have any implementation in the interfaces. So there won't be any conflicts in the logic. Okay, so that was the discussion about the interfaces. Again, key points here is that we can add the methods. We cannot add protected methods. We cannot what else can we do? We can extend in other interfaces. So maybe I will keep it as the comment. So if there is required in the parent, keep it as the comment. So it is possible to extend the interface inside the interface. And it's possible that the interface extends another interface. But it is not possible to extend the class. Obviously, because interface has less functionality than the class. We cannot extend simple class and then use its functionality. So yeah, we can have the methods. So that's basically the main thing what we can have inside the interfaces. We can define as public, so that would be correct. In fact, there won't be any differences if we declare it as public or not. So this will just simply be as is. There's actually there's no difference between declaring as public or default. That's because we inherit this method, so we will need to implement it, and we can define the access modifier right here under the class where we implement this interface. So there's no difference if we declare it as public or default. And about the attributes, that's the disadvantage of the interfaces, that we cannot declare the attributes. So if we declare something like integer, we'll see that first of all it does not allow to define it because we can't define the attributes in the interfaces, unfortunately. Fortunately we can do it, but what we can do, we can define the constants. Something like that. So we can define the constant values. So yeah, that was to talk about the interfaces. We'll go back to them, and we'll also go back to the abstract classes when we talk about casting, because casting thing is really important, and interfaces play the major role in the casting operations. But yeah, we'll talk about it under casting section. So okay, so we finished talking about abstractions, abstract classes and interfaces. Please ask any questions if something is unclear for you. So I will, briefly, any questions you want to find, you don't understand or you're not sure about, any questions you can ask. So, but yeah, let's move on. And you can write the questions if you want to have such. Okay, so right now, as it stands, we will go to the composition topic. And we already used composition even today, but that's the thing to understand. We need to understand and need to just need to understand that these specific things are compositions, and do not confuse it with, do not mix it with other cases. Basically, what is composition? That's the way to combine multiple objects, one or multiple objects, into one. So we, in Java, composition is used as it is used in object-oriented programming, and we want to combine multiple objects in one. So it basically means that one object contains another object. And as an example, when the composition is used, for example, the library. So the library is the object, right? So that's the object library with the books, with all the stuff, with the building as well, and so on. So, but the library contains the list, the set of the books. So there's the list. In fact, this is the object as well, but so there are different books, and each book is the object as well. So we place the object book inside the library. So in this case, we have object inside object. This is called the composition. Then another example, company. Company is also the object with all the stuff, all the employees, all the properties, COs, and so on. So this is the company, the object. So the company has, and for example, company has CO. CO is also the object. Okay. Can also be considered as object, and list of employees. So also each employee is the object. So in this case, again, we have objects inside the objects, and the objects with different types, and all of them are located under the company object. Then again, we have the object computer, for example, and it contains the hardware, which is many different objects. And another thing which is also really important, and it is also possible that the object with one type contains the object with the same type. And as an example, in your computer, just maybe let's have a quick example. So we have the folder, so we consider the folder as the object. So if we go inside the folder, we will see another folder. So in this case we have folder object, which contains another folder, which is also the object. So there are such cases possible that we have one object inside one object and they both have the same types. So that's also possible. As an example, the folder. Also, if we think about the real life, there can be the box, and inside the box you can have another box. So that also means that this is composition. One object is placed inside another. Okay, so as an example where composition is used. And yeah, so one thing which lots of people mix is composition and inheritance. And just for you need to understand that composition is not inheritance. So you will not have all the features of inheritance. Yeah, the protected and public protected attributes and protected methods you can access from the subclass. These things cannot be applied to the composition. So as an example, again, if you have one folder, the object, and then you have about the folder, about the computer. Yeah, have the hardware, the memory, something like that. Yeah, any part of hardware. Then we have the computer. Of course, the computer is not the superclass of the hardware. Yeah. So if we talk about each detail of the computer, like any port, for example, one port in your computer, then the superclass is not computer, right? Because again, as I said, all the subclasses must also be what is described in the superclass. So if the superclass is computer, then it means that all the subclasses must also be computer, right? So that was what I said about the subclasses. And again about the person, have CEO. So CEO is also the person. Employee is also the person. Then anything what is defined as the subclass of the computer at any level, it should also be the computer. If we talk about the hardware, we cannot say that any part of the computer, just anything like the keyboard, for example, you cannot say that keyboard is computer, or you cannot say that mouse is computer, or any button is not computer. That's why computer will not be the superclass of the hardware. But what will be, we say it is not hardware is not the subclass of the computer, but we can say that the hardware is a part of the computer. So we say that keyboard is a part of the computer. We say that mouse is a part of the computer. We say that screen is a part of the computer, but it's not the subclass of the computer. So that would be different. And if we talk about subclass of computer, we can say that so if we have the class of computer, then we can have the subclass which be, for example, which can be the laptop, for example. The laptop. We can say that laptop is the computer. Then we can have PC, personal computer. We can say that personal computer is the computer. So that's the subclass. And then the laptop is also the subclass of computer. And then the tablet computer can also be I consider it as as the computer. So that is what we say when we have the subclasses. And yeah, so that's just not confuse. Composition and inheritance are different things. And yeah, as some keys here, inner object is not the child of the parent. So if we have objects placed under the not under but inside the object, inside another object, we don't say that these things are childs of the parent object. So these are not childs and there's no parent. So there's the pieces of the objects of the parent source object. We can call it. Then again, as I said, composition is the case when one object is located inside another. We cannot say that one computer, if we talk about the subclasses, we cannot say that that the laptop is placed inside the computer. And that's not the case. We cannot say it, and what it can be this way. And yes, on a private, maybe let's protected. You can't access protected methods from the object. So that would not be the case. Then your object is located in another object. Then you can access. Basically, you cannot access any. This is what we said on the last point. If object A is part of object B, it is not possible to find the reference of object B. So from Java perspective, if you don't have such specific logic defined, by default, for each object each object cannot define where this object is used. If you don't actually provide such logic, additional logic, you can pass the attribute, then store the source object as the attribute. But again, there is no such concept by default created. Then you can access. Then you can go from the attribute which is stored somewhere to the place where it is stored. And it is not also possible to access. So if object A is a part of object B, then from object B it is also not possible to access protected or private attributes from object A, because again there is no relations defined as the inheritance. So only using the inheritance we can achieve that. We can get. We have protected. We have the access to protected attributes and to methods. So again, if we talk about composition, this is not. These things do not work. The same way as we previously work just in the code. In the main methods, for example, we have the variables. So in this case. The composition is also the case where the variables are used. So we have the attributes inside the class, and then using these attributes we access another object. So the rules are absolutely the same as if we use these objects as the variables. So, and the differences, again, in composition we combine multiple objects. We control one object from another. So again, if we have the attribute, then under this attribute, this is the variable, we place the object under it, so we can control it from there. And there are no dependencies on the type properties. So basically, there is no relation from the type perspective. We can have any type with any structure to be used as the as the attribute. No restrictions here. Yeah, so this is what I wanted to say. Yeah, there's nothing specific to talk. We already used composition like even today. So right here. So we used basically this is what I said. We use the class person inside the class, which is also the person. Yeah, this is also possible. Again, if we have the parents, so we have person. Yeah, so maybe that would be also correct if we, for the person, we define the dad and mother, for example. And so right here we can define private person, dad and mother. So we know that dad and mother are the persons. So we actually use person inside person. That's also possible. Why not? Why not? We can do it. That's the way. And we can work with the composition. Yeah. So that's what we used. If you have any questions, please ask. If something is unclear about the composition. Alright, so now we can close this topic, and yeah, I think this one will be mostly for the next time. Yeah, we'll finally finish object-oriented programming topic. That's 21, but that's 15th. January. So today I will quickly introduce about casting, because this is really important thing to understand about reference types, and to use it. It can be in some cases it can be tricky. But basically, what's the idea? The idea is that, as I just said, I already said about polymorphism, we can use one type of object as another object. We can use employee as the person. We can use CEO as the person. So in this case, despite the fact that they are defined as separate classes, they both are persons. And the question may be, how can we use them? Yeah, so in fact, if I don't actually care if the person is the employee or CEO or something like that, I just want wants to work with the person as with the person. Yeah, if I go to the grocery store, it doesn't matter if the person is CEO or employee. So the person just buys its stuff and pays and go out. So it doesn't matter if the person is employee, CEO, or anything else. Yeah. So if person just goes to the store, we don't care who is this person. Yeah, we just want to get the money from the person, and so the person can buy the stuff. Yeah. So basically, what happens? We have the situation. This is basically an introduction. We have the situation when we have the logic, when we have the structure of the code, where we process some kinds of objects. And as in this case, we don't care. As I said, we don't care what is the subclass of the object. Yeah, if we know that the object is the person, for example, the person, then we can work with this object as the person, and we don't need to find out if the person is employee, CO, or anything else. We don't care. We don't care about it. We don't want to care about it. And this, and to help us to work with such structure, what we actually need to do, we will actually need to have the variable, right? That's the attribute or the variable where we can place this object, in this case the person. So what we can do, so basically the operation when we pass, like in this case, if we pass employee object to person variable, what we'll have, this operation will be called casting. Yeah, as we already know about integers and doubles. Yeah, so I'm not sure where it was. Something in math operations. But I will just quickly, for example, here, yeah, right here we already have it. So here we go from double to integer. So to go from double to integer, we need to use casting operation. If we go from integer to double, there's no such cases, but we had such cases. When we go from integer to double, the casting is done automatically. If we the casting is done automatically, it's called upcasting. Yeah? So we go from more specific to more general. Of course, then the more general can be used. Yeah, it's like for all the doubles, all the integers can be used as the doubles, right? So I think that's clear. Because all the integers are doubles as well, but not all the doubles are integers. That's the point. And if we go from more specific to more general, that's as an example, when we go from double to from integer to double, we go from okay, yeah, for primitives that's a little bit different. That works in a little bit different way, but yeah, in this case it is possible, because yeah, in this case that's possible. But if we have an opposite way, yeah, so we can lose some information, or something can be missed, then we define this casting operation. For the objects, it works, in fact, yeah, for the object it works in opposite way. For everything types, yeah, that's crazy way. But so when we talk about primitives like integers, if we go from that may be confusing for you. If we go from more general to more specific, like double is more specific than integer, then we don't need to that the casting will be done automatically. If we go from more detail, from more general to more specific, yeah, because double is more specific, to more general, that's integer, then we need to use casting. For the primitives, it is done in opposite way. If we go from more specific object like CO, if we pass CO to person variable, then in this case casting will always be done. Yeah. If we pass CO to person, this will always be done, and this will be correct, and this will be done automatically. Otherwise, if we want to cast person class to CO, we'll need to use this casting operator, provide the type inside the brackets, because not all the persons are COs. Yeah, so that's the thing. I suggest you to just maybe if you can if you have time, think about if we go in all the persons, all the COs are persons, but not all the persons are COs. And that's why if we have the variable CO, we cannot, just in general, we cannot be sure that the person we want to pass to CO variable is CO. Yeah, that may be the problem. Yeah, and this is the thing we need to think about what to do, and what if we want to, if we have such thing that we need to pass the reference from the person type to CO type. So in this case, that may have the issues, and that will have the issue that will trigger the exception if the trigger exception that there's the problem with casting and type cast exception if the person is not CO and you try to pass the person to CO. But we'll have talk about these cases next time on Friday. So that's just at the moment that's just a short introduction. So yeah, we'll finish discussing all the things on Friday. By today I will again as usually share the code so you can check it, and see you all on Friday. Bye.
Yeah.